Welcome. This one I'm going to show you how to answer this question here. So the square root of 1 minus I root 3 over 2. It's a question from a complex analysis book. Let's take a look here. First, I'm going to rewrite this as follows. I'm going to rewrite it as that same quantity, but it's raised to the 1/2. So I'm rewriting the big square root on the outside as 1/2. Then after that, notice that here I have a 2 on the bottom between the I and the 1. So for that reason, I can split this up further into the following pieces. I can take that 2 from the bottom and just put it over here as 2. So it becomes 1/2 minus I, and then the root of 3 over 2 still to the 1/2. And from here, the next stage is to take a look at the unit circle. So I got this from Wikipedia just for reference. And notice that something here. So that here we have 1/2. So 1/2 basically corresponds like to the x-coordinate of a point, and the negative root 3 over 2 corresponds like to the y-coordinate of a point. So if you look at the unit circle here, what does that correspond to? Well, I'll show you. Take a look. If you come up here, you see at pi over 3 radians or 60 degrees, you have x equals 1/2, but the y equals the root of 3 over 2. So you can't use pi over 3 positive. What you really have to do then is just mirror this down to the other side of the x-axis and just find the corresponding angle. So this is how you can think about it. Take a look. First, you can write over here cosine of pi over 3 minus I sine pi over 3 to the 1/2. Why am I doing this? Go back over here. You see there's a negative between them, between the 1/2 and the I. So up here I also therefore have a negative in that position. But then after that, I can let this slip in this way. Take a look. I can rewrite the cosine of pi over 3 as cosine of negative pi over 3. Why can I do that? Because the cosine function is even. So it makes no difference whether you put cosine of pi over 3 or cosine of negative pi over 3. The value is the same. In other words, for both of these, the value is equal to 1/2. You also see that in a unit circle. You see at pi over 3 above my head, it's 1/2. And also if you come down to here, it's 1/2 over here. Now, the unit circle often shows you big angles that wrap around all the way to 2 pi. So when you look at 5 pi over 3, you really should see that instead as negative pi over 3. It means the same thing, okay? Also notice that here, where it says minus I sine of pi over 3, I've written that as plus I sine of negative pi over 3. And again, why can I do that? Because the sine function is odd. So in other words, you can take that negative and you can slip it back into the parentheses and just change the middle sign to a plus. There's nothing arbitrary here. Everything is following from basic rules. That gives you a sine of negative pi over 3. So again, instead of looking up there at pi over 3 positive, I'm essentially looking here where it says 5 pi over 3. So 5 pi over 3 is the angle you get if you spun all the way around the circle. On the other hand, the other way to see it here is to see it as negative pi over 3, as if you were basically counting where it says 1, 0 in this direction down to 5 pi over 3. So in other words, this way. Okay, clockwise if you like. So you see that that's equal to 1/2. So that would correspond to this 1/2 in this position below me. And you see that at negative pi over 3, the y is the negative root 3 over 2, which would correspond to that part below me. So that tells me that this construction of the complex number is correct, essentially. After that, I can apply the exponential form of complex numbers. So I have negative pi over 3, negative pi over 3, the same angles. So over here, I can write this as e to the I, replace theta with negative pi over 3, and keep that 1/2 in the exponent. From there, I can proceed as follows. I can multiply the negative pi over 3 times the 1/2 to get negative pi over 6. Now I have a single angle. What does that angle represent? Go back to the unit circle. So pi over 6 corresponds to the root of 3 over 2 and 1/2. But I have negative pi over 6. So I have to basically mirror down and take the mirror image of pi over 6 on the other side of the x-axis. So that would correspond to an x-coordinate of the root of 3 over 2 and a y-coordinate equal to negative 1 over 2. So in other words, this would be written as follows. Cosine of negative pi over 6 plus I sine of negative pi over 6. But each of those values you can read from the unit circle. So lastly, is going to give us the answer as follows. It's the root of 3 over 2 minus 1/2 I. So in other words, what it's telling us is that this square root quantity, 1 minus I root 3 over 2, once it's fully worked out, becomes this simple complex number root of 3 over 2 minus 1/2 I. Just to emphasize this point, right? Once you're at cosine of negative pi over 6, that's as if you were looking here at 11 pi over 6 counted this way, So then you just count in the opposite direction down to that point, and that's why it's the root of 3 over 2 positive and negative 1/2. That's pretty much it for this one. Please leave a like and subscribe. I'll see you in another video.